Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm going to give you an update over on our metal planer restoration. We kind of finished this thing out a while back, and I've been playing around with it a little bit in the shop, and quite honestly, been having one little problem with it, and that is that the table on it has just been moving a little bit too fast for really what my needs are. And it's just been giving me some issues, and I've been a little frustrated with it and kind of debating on what I needed to do to go about fixing it. So, kind of catching you guys up that may not have followed along with the whole restoration. This machine was built in the 1890s. It would have originally been line shaft driven. There would have been a line shaft that went down the middle of your shop that would have been powered by a steam engine or a water wheel or something like that. There would have been flat leather belts that came down and powered all the machines in the shop off of one power source. That's just the way this machine from that era was built. When I got it and restored it, I decided that I really wanted to kind of modernize it to an extent where I had a self-contained motor on it. So there is a motor mounted back here in the back, kind of back behind this, goes up to the counter shaft, which all these pulleys here normally would have been hanging from the ceiling and connected to a line shaft. I mounted them to the machine, built some brackets, and it really made this machine where I can move it around if I want to. I'm not, I don't have to have it in the exact spot. I don't have to have stuff rigged in the ceiling of my shop and all the problems and potential things that could go wrong with that. So I really like my setup. But in the process of doing it, because of the belt sizes or the pulley sizes or whatever, even though I'm running it according to the book, kind of at about 20 feet per minute at its normal speed, which is within the range of what is recommended, it's still just a little bit too fast. At least I feel like it's a little bit too fast. And depending on the material that you're running in, you just really need to be able to control that speed a little bit. Back in the flat belt days, they would have had step cone pulleys that you could have shifted belts around to be able to do that. I didn't have step cone pulleys for this one. All that stuff was gone. And I basically just have one speed going from the motor to the counter shaft up top. So I really didn't have that option. So my solution is using, again, a little bit of a modern technology. I am using a variable frequency drive to actually power the motor and do some motor controls. And one of the really neat things about a variable frequency drive is that it can actually give you variable speed in a three-phase motor, which is what this is, a three-phase motor. So anyway, we're gonna kind of walk you through this, show you this whole setup, talk about what all we had to do. The work's already done. I actually had a friend of mine, Nils Lima, who is an electrician by trade, does a lot of control wiring in his profession. He's been to my shop several times. He came in for a couple of days, a week or so ago, and he was kind enough to actually get this thing all wired up and hooked up for me. I've done them before, but I took advantage of his help, and unfortunately we didn't get any video of that because I actually wasn't even in the shop during a lot of the time that he was working on this. But I am going to kind of go over what all we did, talk about VFDs, their pros, their cons, and show you this new machine, the way it works out. Let's get at it. So I think what I want to do is kind of start at the end and work forward because you guys want to see what this thing is all about. So if you look over on the side of my machine, I have an electrical control box on here. And one of the things we did is we upgraded this or downgraded it, depending on how you look at it. I was able to find, actually, Nils, my friend, he found this for me. This is a vintage start-stop button station here that he salvaged off of an old piece of equipment. And it just looks right on this antique machine. Before I had a more modern push button start control station. Does the exact same thing. This one is just an old one and it looks cool. We got a start button, we got a stop button, just like we had with the motor starter that we were using before. We've also got a little light that lights up whenever this thing is powered up so you can see that the power is going to it. We had to make a little custom box for this. I need to change my bracket around a little bit. It's not exactly where I want it, but you can see everything working on it the way it is. The other thing that we did on this is over on the side of this, there is a potentiometer, which is a little rotating switch for you non-electrical guys that don't know what that is. And when you rotate that, basically it's changing I guess the ohms that comes out of it, but that feeds over to the VFD, and that's where my speed control comes from. So on this, I got a knob right here on the side. I dial it in, it controls the speed. And to show you how it works, let's start her up. We hit the start button, The machine starts up. You can see the table moving in the background. You can see the belts going. I can speed it up. And I can speed it up by just turning that knob. Slow it down, same way. Got a very nice range of speeds. And just like before, when we stop it, we push the stop button. It goes to the variable frequency drive. This is what's controlling the motor. But this is what that VFD is allowing me to do. It's actually allowing me to do several things in here, but start, stop, and the variable speed is the main thing I wanted. So let's talk just a little bit about what a VFD is. A VFD stands for variable frequency drive. It is for running in a three-phase motor, alternating current. Of course, you can get them for whatever voltage you're running, and you get them sized for whatever size motor you want to run. And really what a variable frequency drive or a VFD is truly designed for is motor control. You can do all kinds of motor control functions with a VFD. And honestly, what I'm using it for here only touches on the things that you can do with one. But for a machine in a shop like I'm doing, I'm probably utilizing the main functions that we want. You just saw we have start stop functions in there. So your VFD basically is going to replace your motor starter. Your motor starter is where you push the buttons and that's what goes over there. Contactor comes in, makes the connection. It has overload system in there, so the motor draws too many amps, it will actually automatically kick it out so it doesn't burn your motor up. Used for years and years and decades, motor starters, and still used today. A VFD replaces that. It does all of that. So that's the basic, very, very most basic things it does is motor starter functions. And you know, if you don't need a lot of the other controls, you don't necessarily need the VFD. But in my case, we wanted the variable speed. So the variable speed, again, turning that knob, that is where the variable frequency comes into the whole play. So variable frequency drive does that. It just does just that. It varies the frequency of the electricity. So your electricity in the US, we're on a 60 hertz system. So every second you have 60 cycles in that alternating current. It goes from the top to the bottom of that cycle 60 times per second. And the way a variable frequency drive works is when you turn that knob on the side, it changes that frequency. It can change it above 60 or below 60. I have mine programmed 60 is the max. You can't actually go above cycle by a certain percent, and your motors can handle it, and you can go down in your frequency. And when you change that frequency, it changes how fast that motor turns. So the lower the frequency number, the slower the motor turns, the higher the frequency number, the faster the motor turns. So again, variable frequency drive. Not gonna go into how it all works because it's really complicated. I have a very vague understanding of it. I'm not even gonna try to explain it. But that's what happens. You're changing the frequency or how many times that it cycles per second your electrical, and that is good for speed control. Another thing that we have this VFD programmed to do is it gives me a soft start. And when I say soft start, when I turn that motor on, it's not automatically turning. It just goes from 0 to however many RPMs it's going in just a split second or as fast as it can wind up. Which is with a typical motor starter. When you push that button, that's what it's going to do. It's going to go from 0 to its maximum speed just as quickly as it can get there. In some applications, that's fine. With this, I actually want it to speed up kind of slow, relatively speaking. I've got this one programmed where it takes 5 seconds. So when I push that button, it takes 5 seconds to go from a dead stop to whatever speed that I'm running it at. It also has a motor brake on it. It does the same thing. It will stop that motor in 5 seconds. Again, with the old motor starter, when I hit stop, it's just gonna keep spinning until it spins down, and depending on how much drag is in that machine, you know, something like a grinder that's balanced really well, I mean, I can turn some of my grinders off and 20 minutes later, they're still spinning. So with this, it actually, the VFD will actually slow that motor down and stop it within that 5 second period. And you can program how long you want those to be all in there. So that's the main thing that I'm using my VFD for, are those functions. And again, that is what a VFD is designed for, is motor control varying the frequency in a lot of these motor control operations. These VFDs, they can be fairly simple, they can be fairly complex. Some of them are a lot easier to program than others. One thing that I would caution you about when you're shopping for a VFD, before you buy one, download the manual and make sure that you can understand it. A lot of the VFDs that are made today are made in China. And you know, some of them are probably better than others, but I can promise you that some of the manuals are better than others. And if you can't understand the manual, you're not going to be able to get that thing programmed right. And I have seen some of these manuals coming out of China that, yeah, you just can't make sense out of them. So look at that real close. Now, in my shop, this would be the third machine that I'm utilizing a VFD on for motor control. I've got a couple of wood lathes that I also use it on. On both of my other machines, I used a Hitachi brand VFD, and I've been extremely happy with those. And honestly, when I went to do this one, I was looking for a Hitachi brand VFD. I actually reached out to my friends up American Rotary who actually sell Hitachi VFDs. Unfortunately, right now, this video is being taken kind of at the tail end of the whole pandemic thing that's going on. We've got all these global shortages and problems going on, supply chain issues. It was going to be like a 9-month wait to get the VFD I needed for this machine made by Hitachi. I was a little bit bummed on that, but I started doing some research. I talked with the folks at Automation Direct, who is a supplier for motor control type stuff, and they had a VFD that they told me would work really good, and that's the one I ended up purchasing. I'm going to let's take a look at it and talk about that one for just a minute. So we're looking over here kind of on the back side of the machine. I got this thing mounted exactly where I had my motor starter mounted before, and I actually used the same bracket. I had to modify it a little bit to take it on here, but this is the VFD that I got. Again, I got this from Automation Direct. This is a Iron Horse is the name of it. This one is designed for a 5 horsepower 3-phase motor at 3-phase, or you can run a 2 horsepower single phase motor off of this. If you put some jumpers in there and you run it, basically power it with 220 volts single phase, you can run a 2 horsepower motor. That's one of the cool things about VFDs is that you can use them for is actually creating 3-phase power. I have a rotary phase converter in my shop, so I'm generating my rotary phase power, my 3-phase power using the phase converter. And because of that, it's actually cheaper and more efficient really to use the 3-phase input than it is to use the single phase input. We'll talk a little bit more about that in a little bit. But anyway, this is a 5 horsepower unit. Again, Iron Horse is the brand. I'm actually pretty impressed with this unit. It comes in a nice, this case all the way around it. It's a plastic case, but it's a real heavy, rigid plastic material. It's actually got knockouts in the bottom where you can put electrical connectors into, which really makes mounting your electrical stuff in here a lot easier. With some of the VFDs, you almost have to put your VFD in an enclosure in order to get your electrical fittings into it because it's just got a little cheap plastic case on it. This is a heavy duty plastic case that's on here that can actually hold those electrical connectors. This one has a heat sink on the back. So you got a big aluminum piece in there with the fins in it. And the nice thing about that is it doesn't need a fan to cool it, which a lot of your VFDs have a fan in them. And while those work really well in a shop that may, be delivering a lot of metal chips or sawdust or whatever, that can all clog up your fan and your screens, and that can cut down on your cooling ability. So using these fins back here, I think, is another big advantage to this one. All in all, I'm pretty impressed with it. The readout on here, this is actually the frequency that it's at right now. It's at what, 37. When I turn that knob over here, you see it changes. It goes up to a maximum of 60 hertz, and I actually got it where it'll go down to 0 or any infinite number in between. And you can just kind of dial it in to whatever speed looks right on your machine to be able to run it on. So that's the actual unit that we got. Again, that particular one came from Automation Direct. When you get the VFD, it comes with a couple of little pamphlets in here that have the basics on doing it. There is a manual you can download online that really gets down in the weeds for doing a lot of the really fancy programming, but probably 90% of what these things done are handled on these diagrams real here. Now, I could pull the covers off and show you the wires up inside of there, but it'd be hard to see it. So I'm going to show you on the wiring diagrams what we did on mine to get it going. Let me zoom in a little bit tighter over here. So first off, we're looking at the power connections coming in here, and we got several things going on. This is three-phase input, and it also covers a single phase as well. But basically, you've got your line, your power coming in, your three-phase power coming in, and it tells you put it on this R, S, and L, which is your L1, L2, L3, your line input coming in. Now on this one, it says for single-phase input, only use the R and T terminals, which will be L1 and L3. You don't put anything on L2. With this particular VFD, it is smart enough to be able to recognize that you have single phase power coming into it, and it will automatically take care of what needs to take care of it. In some of the VFDs that I've done, if you're powering it with single phase instead of three phase, you have to put a jumper between one of these. So you're basically forcing the voltage to go over to one of those other terminals to go into it. It's out of phase, but when it goes into the VFD, it kind of cleans all that up. Now, as far as coming out, you have these three terminals over here, U, V, and W. Those are the three wires that go to your motor. So your power goes into this one, it comes out of this one, and it does all your fancy work that's done inside for motor control electrically is all done inside the unit itself. There's some stuff in here for brake resistors. If you really want to stop a motor really instantly, you got to have a resistor in there to be able to take that. I'm not using that I'm slowing it down slow enough that I don't need that in this particular case, but you got some options to do that. Let's look at some of the other wiring that we had. Now, as far as your on-off switches here, you got a couple of different options on how you do it. So this option is if you got like a toggle switch where it's either on or it's off. And you can wire it up. There's a common line that comes in here, and you've got two of them. One of them is for forward and one of them is for reverse. You would probably in this situation want to have a switch where it could only be on one or the other, like a toggle that switches up for forward and down for reverse, and then the center is off. But basically you have that common that goes in there, and then you connect it over to those two terminals, and boom, you got your power going. So in this case, when the switch is in the off position, it turns the motor off, and then you're either switching on forward or reverse. And that's another thing a VFD will do. It will reverse the direction of the motor for you. No need for a reversing motor starter. It's all handled internally inside the unit itself. On my wood lathes, this is how I have them connected, where I just have a three-position toggle switch, and it's either in forward, off, or reverse, depending on what position I have that toggle switch. Now, with the push-button stations, you use this wiring down here, and it's a little bit different. And in this case, you got your stop. There's a forward and reverse. These have the momentary switches in there. The start buttons for either forward or reverse are normally open. When you push the switch in, you have a closed circuit, and that triggers forward or reverse. And then for the stop, it's a normally closed button, and when you push it, it breaks the circuit and shuts everything off. Very similar to how a motor starter is wired. The wiring diagram is different, but you use the same push button stations like you would use with a motor starter. In my case, I don't have reverse wired in here. I've only got a forward because this machine really doesn't have a reverse. It only runs in one direction. The table goes back and forth on it, but that's built into the mechanical controls of the actual metal planer itself. So I don't have a need for reverse. In many machines you do. In this case, we just didn't wire the reverse up, so we just left it blank. Now, as far as the frequency input, as far as the potentiometer is concerned, again, you just come in here, there's three wires on that potentiometer, and it tells you exactly where you put them in, and you got all of your wiring that you need to do. And the only other thing that we really did with this one is we've got right down here, we connected into the circuit, and it's pulling off, whenever the motor is running, it's pulling off a 24-volt circuit, and that's what powers the lamp that's up in my control station. Really not necessary, but we had that lamp in that particular push button station and wanted to utilize it. Wasn't a problem. We were able to get it off of here. So all in all, the wiring is fairly simple. There is some programming that has to go on there. There's directions in here. You need to go in there and put in information, on your motor, how many RPMs it turns, how many horsepower, how many amps, is the motor rated for. There's all that kind of information you program in, but again, it gives you step-by-step instructions on how to do it. This particular one is fairly easy to follow along. If you're halfway decent at doing basic wiring and can follow simple instructions, you should be able to install one of these yourself without having to bring in an electrician to do it. If you're not certain about yourself, I would definitely encourage you to just hire an electrician to come in and do the work for you. So another thing I really want to talk about in this video is, and we've already kind of mentioned it a couple of times, but you can power these variable frequency drives with either single phase input or three-phase input and get three-phase input out of it. So basically, you can use the variable frequency drive as a means to convert single-phase power to three-phase power. Very handy if you're needing to run an industrial machine and say you're in a small garage shop and you don't have access to three-phase power off the line. My shop here, while I've got a pretty good large size shop, all I have is a 220 volt single-phase power coming into it. I got a 400 amp service, but I do not have three-phase in this building. So the question comes up all the time. There's probably more ways to make three-phase power from single-phase, but two main ways it's done. One is with a phase converter, a rotary phase converter, which is the way that I kind of do mine, or you can just use one of these VFDs and take care of it that way. And I get a lot of questions on my channel. Hey, should I buy a rotary phase converter or should I buy a VFD? If you go to the discussion forums on the internet, you ask a question like that, you're going to get 432 answers and they're all going to be different. And everybody has their opinion about it. I have my opinion about it and I'm going to share my opinion about it. First off, if your goal is to create three-phase power, they both work. You can either have a rotary phase converter, create dedicated three-phase power, or you can use the VFD to do the exact same thing. When should you use what? So in my mind, okay, and this is kind of my thinking. So first off, when would you want to use a VFD to create three-phase power? Let's just go at it this way. When would you want to use a VFD to create three-phase power? In my mind, number one, how big is the motor that you're wanting to control? If it's a fairly small motor, 2 horsepower, 3 horsepower, something like that, really 1 or 2 horsepower motor, a VFD makes good sense in a lot of situations. Also, next question I'm going to ask is, how many machines are you wanting to run that are three-phase powered? Are you, okay, I just bought a milling machine that's three-phase, and that's all I'm ever going to put in my shop is this three-phase milling machine. I'm never going to bring another three-phase machine in here. This is a one-time deal, and I'm not going to do it. Now, first off, if you go out and buy a three-phase milling machine and you really think that you're never going to buy anything else three-phase after that, you're probably kidding yourself. Let's just face it. But assume that's the case. It's a good application for a VFD. You only got to buy one VFD. You can put it on there. One of the problems with these VFDs, or maybe it's not a problem, but one of the things you have to think about with them is that your VFD is sized for the motor that you're going to run with it. So let's say you buy that milling machine that has a 2 horsepower motor on it, and you get this exact VFD I've got over here, which will run 5 horsepower motor at 3-phase input or a 2 horsepower motor at single-phase input. You put that VFD on there, you're up and going. Well then, 2 months from now, 2 years from now, I decide I want to get a metal lathe, and it has a 5 horsepower motor on it. Well, guess what? That VFD that runs your mill, it's not going to power your lathe. And here's the other thing you can think about. Let's say that you've got 2 machines that are both 2 horsepower. Can you use one VFD to power both of them? Yeah, but remember when I talked about programming it? and you got to put in the motor RPMs, and you got to put in all the information on that motor. Well, if both machines have the same motor or the same specs, yeah, you can pull that off. You can only run one machine or the other at any given time, but yeah, you can pull that off. But if you got two different motors that have different RPMs and stuff, you really, maybe you don't have to, but you really need to program that VFD for that motor. So now you really might need to have two VFDs instead of one to convert it. And if you're like me, I think I've got 25, 30 machines in my shop that run on three-phase. I can't afford to put a VFD on every single one of them. I just can't do it. So for me, the phase converter is the right answer, because I got one piece of equipment in my shop that is generating three-phase power, and I can run any machine in my shop off of that three-phase power that's generated off of my phase converter. Another things to take into consider, remember we told you that that one would run a 2 horsepower single-phase motor or a 5 horsepower three-phase motor. Okay, well, let's say that I've got this metal planer sitting in my garage and I want to use a VFD and power it with single-phase power. Can I do it? Absolutely. Can't use that VFD. I've got to get a bigger VFD that will basically run 5 horsepower off a single phase. And I just happened to go look and see what that VFD would cost. So I went to the website. I think this is what I paid for that one. It's been a month or two ago. It's probably pretty close. The one I got over here, $351. You can buy them cheaper, but remember, not all VFDs are created equal. Do your homework, get a good one, get one that has a manual you can read. I feel like that's a pretty good one, $351. That's probably a average price for, a decent VFD for 5 horsepower, three-phase input. Now to get the one for 5 horsepower single-phase input, it's $586 for that VFD. Oh, and by the way, I'm running this over here. My three-phase input is running on a 20 amp circuit, okay? If I was running it on 220 volts, single phase, I would have to run it on a 40 amp circuit. What's the big deal? Well, now I've got to run wire from my breaker, my panel box in there. Instead of running 12 gauge wire, I'm gonna have to run 8 gauge wire over here. The point is it starts getting expensive after you put in a couple of these VFDs on single phase. If you're running everything on three phase, my wiring is cheaper, my breakers are cheaper, the VFDs are cheaper, and they're all doing the same thing. These VFDs are designed to run on three phase, but they will run on single phase. So keep that in mind. If you've got more than just a couple of machines, you're probably better off just biting the bullet, buying a phase converter, and in many cases, you don't need the motor control aspect, you just need to get power to that machine. So you're really not even utilizing the motor control aspects of that VFD. So, do your homework. There really is no right or wrong answer to the question. There are a lot of factors that can go into that decision as to what really is the best answer to that question. But at the end of the day, if you think that you're gonna have more than, say, 2 or 3 three-phase machines in your shop, you're probably better off to bite the bullet, spend a little bit extra money, get a phase converter, and just be done with it. Because again, most cases, you're not even gonna need a VFD unless you wanna do something fancy like I'm doing here. Phew, that was a lot of talking, and I apologize for that, but there's a lot of stuff to talk about this, and I probably only scratched the surface of it. So before we get out of here, let's watch this machine run a little bit more, because it's just cool. So we'll let that run a few cycles for you while you're going, so you can kind of see that play around over there. I'm really, really happy with the results that we got here. My metal planer is running good, it's in good shape, and I'm really ready to start using this thing in the shop now. And I've got some jobs coming up real quick that we're gonna be using this on. Getting a lot of questions about the steam stoker engine. That's what we're gonna put on the planer now that we got all this sorted out. Coming soon, steam stoker engine on the metal planer. Can't wait. So there we go, guys. That is going to be a wrap. As always, thank you so much for watching. Please hit the subscribe button if you haven't already. Comments greatly appreciated. Hit the bell icon to get notifications. Patreon supporters, big thank you to you guys. You know, I was able to use some of the money that I got from you Patreons to get the equipment to put on this machine to really get it set up right. If it hadn't been for you guys, it'd have been a whole lot harder to do. So big thank you to you guys. And with that, we are going to sign off, and we will catch you on the next video. And hopefully you can see this machine making some chips coming up real soon.